Welcome back to Calculus. So today we are ready to jump into integration by parts, and this is a really nice section. This is going to help us take derivatives of things that are products. So it's kind of our answer to product rule, really. So we're going to be able to do things like the integral of x sine x. We're going to be able to do things like the integral of x dx, x ln of x dx, x e to the x dx. So these are composite functions, really. Two different types of functions. So like the first one was what? Polynomial, trigonometric, polynomial, logarithmic, polynomial, exponential, even things like exponential, trigonometric. We'll be able to do all these kind of things. And then kind of the real gem is even this we'll be able to do, which doesn't look like a composite function, but we can make it work with this integration by parts. So these are things we'll be able to do, and we're going to cover most of these in class today. The rest you'll see in your assignment. So how do we get this new formula? Well, what we're going to do, what somebody did one day, was they were looking at the product rule. So to remind you, the product rule says the derivative of a product, like u times v, is the first times the derivative of the second plus the second times the derivative of the first. Now, what can we do with this? How can we use this to our advantage? Well, what if we were to, actually I'm going to rewrite this like this. You got to really be careful to distinguish your u's and v's in this, and that's pretty standard to use u's and v's. So you want to be used to that. What if I were to integrate both sides? Could I get something useful out of this? Oh, I didn't mean to do that. If I were to integrate this and integrate this, what would happen? Well, on the left side, integrating a derivative, those are kind of like inverse operations, so we're just going to have the uv left. On the right side, there's not much we can do because we don't really know. I'm just going to rewrite this as this, break the integral into two parts, u dv plus the integral of v du. Okay, so we have this. What use is this? Well, what we're going to be able to do with this is, if I solve for this part here, I'm going to have a nice little formula. Integral of u dv equals uv minus the integral of v du. So that's actually going to be really, we're going to be able to kind of transform the look of something. So if you have something in this form, it's telling us we could put it in this form. And maybe, just maybe, in this form you can't integrate it, but this you can. And this is already not an integral. So that's kind of the idea. This is called, again, integration by parts. And to tell you a little secret, although you'll hear this a lot from me, I don't use this formula. Okay, I guess I use it, but I don't think about it in this way. I feel like it's pretty hard to memorize that way, so I have kind of a really nice visual that I use that's helpful. So probably the best way to see this is in some examples, and I have 6 examples I want to do. Probably have to split this into a couple videos, but let's take a look. So the first one we're going to do, called example 1, was one of those I mentioned up top in the very beginning of this video, the integral of x sine x dx. So the task in these is to think of that as this. So part of this is going to be u, part of it's going to be du. So where's my u? Where's my, dv? Part of it's u, part of it's dv. Where's my u, where's my dv? Now the dx will always go into the dv. And so what I'm going to encourage you to do is set up a u du I always orient this way. And you're going to figure out what is you're always going to know, whoops, let's change the color up. You're going to figure out what goes in the U space and what goes in the DV space. So the U, let's try simple here and just let U be the X. And that would leave, so if U is X, that would leave all of this for the DV. And once we're done, I can kind of reflect on this about why we did this, but I can just tell you the only other option we had, there's only really other option, was to put the sine X here and the X here. So you're just kind of deciding who goes where. That was the only other option, and there's a little problem with that we'll explore in a moment. So to complete this technique, we have to figure out what is du. Well, if du is the derivative of u, so this is just dx, 1 dx. And what's my v? Well, to get up here, I have to integrate. It's the integral of sine x, so it'd be negative cosine x. So notice your bottom row is always going to have the dx's. Your top row will never have the dx's because your bottom row are the d's. The top row are the non-d's. So now using integration by parts, I'm going to kind of do it their way and then I'll show you my way. Whoops, don't need that. It says you can transform this to this. So I'm going to write, it says, the instructions here say write uv. So I'll write x times negative cosine x. Okay. Then it says write a minus. Then it says put an integral. Then it says put your v. Then it says put your du. And you're like, okay, well, what's happened here that's actually really helpful? And move the negative out through there. Well, what's happened that's really helpful is the thing out front is this is a product, but it's fine. It's out of the integral. It's safe. But the thing in the integral is no longer a product. I know that integral, right? It's sine x. So my answer is negative x cosine x plus sine x plus c. So what often happens is, here's kind of the big key move, is when I took the derivative of u, it didn't have any x's in it. It just became dx. So at the very end, when I joined up v and du did not make it a product. V and du did not make it a product. So here's how I do this quickly without having to look at this ever. It's all about the picnic table. Okay, so let's go with green here. So always orient it this way every time. And if I don't orient this way, this would not work. And I remember that you always start with this, u dv. So start with that, kind of moving in this direction. Then you say equals, and you do uv, moving in this direction. And then finally, you do v du. So looking at it again, moving in this direction here. So it was u dv, which is that. I'm not even going to label them now. And then it was uv, which is that. And then it's v du, which is that. So it kind of has a picnic table look to it. And that's all I do. I know it's going to work. I know it sets up. And I never think about this equation. I just always orient them in this way. And then I always do that, then that, then that. Maybe we could label it 1, 2, 3 or something. 1, 2, and then wrap it up, coming up down here. Or 1, 2, 3. And there you go. Okay, let's try another. Once you get the hang of this, it's so nice because you don't think about the formula at all. So next up is, I think the second one I had up there, x ln x. Let's get rid of some of these. Okay. So what is my u and what is my du? Or what is my u and what is my dv, I should say. Well, what really worked well up here was x being my u, because the derivative of x is just dx, and that was really the whole breakthrough, because then when I did v du, the second leg of my picnic table, it didn't have a product any longer. So let's try that again. Put x there and put the ln of x dx here. And this is looking really good, but then here, oh, we don't know how to integrate ln x. So this actually is not going to work. It's okay. Sometimes that happens. So there's only two things to try. Let's try ln of x here. So then x would go here. Now ln of x dx. You always put the dx down here. ln of x, we knew how to take the derivative. We just can't take the integral. It's 1 over x dx. The derivative, or the integral of x, is 1/2 x squared. Okay, we don't need to put plus c's. You don't need to do that. So our picnic table says you start with that. Oops, let's make sure that's a different color. We started with that. Check, right? X, ln x, dx, everything's there. Then we do this. So that will be equals, and this is like, oh no, not looking good. I just put the ln x in the end. Doesn't really matter the order of multiplication. Then it tells me to put a minus sign. Then we do an integral. And now we do the last leg of the picnic table, which you're going to see why this is going to work so well here in a minute. It's 1/2 x squared times 1 over x dx. You see what's going to happen? What happens is, we can bring the 1/2 out front. This just becomes x, because the 1 over x times x squared is just x. So that 1 over x there, in the end, became the key player in this, in knocking down the x squared to x, and we can actually do this. And this is how they all work, basically. So this is 1/2 x squared times ln of x minus 1/2 times 1/2 x squared. Now we need a plus c. In other words, I mean, you could factor a 1/2 out of here. You could factor a 1/4 out of here if you want. Maybe I'll do the 1/4 at the end. Minus 1/4 x. Oh, and we could factor out x squared. That's really our answer, but we could clean this up a bit. Factor out x squared over 4. And this would be 2 ln of x minus x, nope, minus 1 plus c. Okay, and that's okay if you left it there. Well, let's get to the, how are we doing on time here? Let's get to the really interesting one that we've all been waiting for, I'm sure. The integral of the natural log of x dx. How does this fit in integration by parts? Well, let's say you were forced to try it. What would you do? Think, well, I don't know, I guess. And it worked really well letting ln be u, because we know the derivative of ln, we don't know the integral. So we're going to learn that if you have a natural log, a logarithmic function, it's always u. But then it seems that there's nothing left for dv. Well, there's dx. And the integral of dx is just x, right? So I might be like, what's happening here? Is this going to really do us anything? Do us any good? So we did, the first part was that. That's right. And now we do this, x ln x. Then we do a minus. Then we have an integral. And finally this part. Look at this. X times 1 over x dx. Ooh, there should be a dx there. And that is x ln x minus just the integral of dx. And that is x plus c. you could factor out the x, and you get a really nice looking answer. X times the quantity natural log of x minus 1 plus c. Look at that. We now can integrate ln of x. Really exciting stuff there. I have 3 more examples. This is going to make this a really long video, so I think I'm going to stop it here